And now we enter the next phase. And this is not necessarily part of the curriculum. What we're doing in this next phase is applying everything you've known or everything you've learned in a very specific way. Games are a fantastic way to demonstrate knowledge and skills. And the reason being is that depending on the game you build, you can really go in depth on any given topic that we've learned in any of the courses that you take at Stephen Lewis Secondary School, whether that's the grade 10, the grade 11, or the grade 12, which is why it's such a big focus for your teachers. And you're going to find that it's going to be a great way to demonstrate your abilities. Now, so let's get into this. If you want to make a game, you need to understand this idea of a game loop. Every single game, interactive game that you've played, really relies on the same thing. Now, it's not even just digital games like video games. Even board games kind of work on the same idea as well, to a different degree or in a different way. Let's talk about how it works in our video games. The game itself is made up of 3 parts. Now, the first part is called the load. So in this section, everything we do in the load is loading things like media. So we're talking about images, videos, sounds, all that kind of stuff. And also just game data. So that might be things like setting up starting scores. It might be setting up player information and all that kind of stuff. So media and game data, that's what load is all about. Getting all that stuff ready to go. And this happens once per program. One time. It happens at the very beginning of the program. Once the load is done, then we get into the loop, the game loop. And the game loop is made up of 2 parts. So I'm going to write the word loop here so you understand where this loop starts. And this is a loop forever approach. All right, loop forever. What happens in this loop? 2 things happen in this loop in this very specific order. The first thing that happens is update. An update always has a variable that's part of it called a timer. And this timer is typically, depending on the tool that you're using, but what it typically is the amount of time since the last time update was called. So the amount of time passed, pardon my handwriting, since update was called last. And what this does is it allows you to keep track of what's going on in your game. So, for example, you might have objects that move at a certain speed based on time. So how far do they move in a given time interval? So you take that time that's passed into account and you move them the corresponding amount. It might also be used in timers within your game. So, for example, maybe your player only has a certain amount of time to pass a level. So you can subtract the amount of time passed since the last update from your overall timer, and you can see it reduce piece by piece, piece by piece. Now, typically this is measured in milliseconds. So what do I mean by milliseconds? So milliseconds is just a smaller unit of measure. So 1 second is equal to 1,000 milliseconds. Okay, so keep that in mind going forward. So I'm going to come back to the update in a second, and because that one is a little bit more detailed. The third thing and the last part of the game loop is the draw. Now, what you need to realize is that no game logic should exist inside the draw at all. Absolutely none. The only thing that should exist inside the draw is just draw commands. The only logic we should ever see is if statements that say, in this scenario, draw this. Otherwise, draw that. And it might be, say, for example, if it's player 1's turn, then you'll draw player 1's stuff. If it's player 2's turn, then you'll draw player 2's stuff. So it might be if statements like that. But that's the only logic you should actually see in here. So I'm going to leave that for a second. But the purpose of draw is to draw all the current game-related data. Now, I'm going to leave that kind of open-ended for a second. So draw current game-related data. Now, the word current is what matters here. We'll come back to that. So why did I leave update so open? Well, because update is made up of a lot of different parts. What happens in update? What are we updating? Well, we're updating the whole game itself, all of the logic involved. And usually there's a very specific order that this occurs in, but depending on the game, you may want to actually vary that order. So this is the normal standard order. Again, you can change this as you think you need to. It depends on your game. So the first thing that's going to happen is typically you're going to get input. You're going to get user input. So get user input. All right. Now, of course, from that user input, you're typically going to react in some way. What does that mean? Well, maybe you're going to move your character. Or maybe you're going to jump. Maybe you're going to slide. Maybe you're going to buy something. It can be anything that the player can do. It might also be the player reacting to other things. It might be like a counter attack in a fighting game or something like that. So there could be all sorts of different things going on. So get user input is typically the first thing that we see. The next thing is to update the world. So update the world. Now, what do I mean by that? Well, there's a lot of things that are involved in the world. So things like game timers, environment items. So maybe you're creating a game like a tower defense game and you have to harvest resources. So maybe those resources regenerate after a little while. So environment items. So this update world would keep that timer going. Would keep that timer going so it gets that much closer to a full regeneration, things like that. Of course, there's other things as well. Maybe it's like a day-night cycle that you have going on. It could be anything that's involved in the game itself, in the world itself. So day-night cycle. Whoa, spelt that completely wrong. Okay, so once your world has been updated, now there's lots of more obviously, but these are just giving you some ideas. The next thing is to update game objects. So these are kind of like living entities or entities in the game that interact with each other or other things in the game. So update game objects. Well, what does that mean? So it could be like NPCs, so non-player characters. So what do I mean by NPCs? So these might be enemies, they might be shopkeepers, they might just be random pedestrians on the road, they could be animals running around, anything that any active entity in the game that is not controlled by the player but controlled by some form of AI to a degree. So this might involve artificial intelligence, so AI. Or, of course, it may involve things like moving things that are already in the process of moving. So maybe that might be like physics and that kind of stuff. So physics. And what other things do we do on that type of stuff? It might be just updating scores, positions, that kind of stuff. Oops. There's so many different things that go on in here. And then we get to the last one, and this is not always the last one. It depends on your game. I usually like to do this one at the end. Collision detection. This is detecting whether any two things collide and what to do as a result of them. So, for example, if the player collides with a bullet, maybe the player takes some damage. If a bullet collides with an enemy, maybe that kills the enemy. Or if it collides with the wall, maybe it destroys the bullet. Maybe it even causes damage to the wall. If the player collides with a power-up, maybe they pick up that power-up. It depends on the game. And sometimes you just ignore, sometimes you don't care about certain collisions. So like if a leaf is flying through your game and it collides with a cloud, do you care? No, you don't. So you just let it keep going. Not everything should be colliding with everything else. It depends on your game. Every game is going to be completely unique. If you're making a game like Tetris, for example, then you're looking for that collision with the objects below it so it can stop moving and possibly create lines and so on and so forth. Okay, so that's basically everything that goes in the update. And I said the draw is all about drawing the current game-related data. So what do I mean by current game-related data? Well, to understand that, we need to understand something called game states. Now, your game can be in any one given state at a time. So this idea of a game state, let me give you some examples, and I think it might come clear pretty immediately. So for example, your game might be in the menu state to begin. From the menu state, they might go to, say, for example, the settings state. Or they might go to the instructions state. Or maybe they'll go to the gameplay state. From the gameplay state, they might go to the pause state. Or there might be an end of life state, or let's say end of round. Or end of game. And there could be so many more. The point is when we think of these states, the update and the draw change based on what state you're in. So for example, all of these things that I put underneath update, these really only occur when we're in the gameplay state. Right? Well, what about things like the menu state? Yeah, I'm going to get the user input, but the user input's going to react in different ways. So for the menu state, user input might be like navigating a menu, moving up and down through choices of a menu. If you're in the setting state, that might be looking at things like tweaking different settings like volume and things like that. If you're in the pause state, it probably doesn't do much other than return you back to the game from the pause state. So you can see the game logic changes and is very specific to the state we're currently in. Similarly speaking, down in the draw method, again, the game state the game state dictates everything. So if you're currently in the menu state, then you draw the menu. You draw all the buttons and all the options and everything like that. If you're currently in the gameplay state, then you draw all the gameplay action. If you're in the pause state, maybe you draw the gameplay action and some type of thing on top of it that says currently paused, press enter to continue, that kind of thing. So all of these pieces to the puzzle, the way that we deal with this is we use things like switch statements. So we might like a decision, either an if, else if, or a switch statement. So you might have a switch statement right here, switch game state, where game state is the variable that holds what state you're currently in. And then inside you have a case for every single state. So when you're in the menu state, then you draw the menu stuff. And then break, of course. And then you might have another case for your settings state. And then, of course, you draw the settings. Now, and of course, there's more going on. This exact same switch statement would occur in the update loop or the update method as well. Exactly the same. The only difference is instead of draw menu, you would do menu logic. Or update menu, as I like to call it. Same with settings, update gameplay, update pause, update end of round. So that way you're only doing the logic for the state that you're currently in. And the best part is all you have to do is manage that by a simple variable. So let's say, for example, the player dies in the middle of the game. All you have to do is say game state equals end of round state. And all of a sudden, the next time through the loop, it comes back up, and inside the update, it uses that switch statement. It doesn't go to the gameplay state anymore because now game state is now end of round. So it immediately jumps down to the end of round stuff and handles the logic for that. Similarly speaking, in the draw state, it'll jump immediately down to the end of round state. So you don't have to do anything special other than manage that game state variable, and your game will always look the way you expect it. It makes things really smooth and work really well with one another. So this is the same in pretty much every game you've ever played, and it won't really change throughout our course as well. We're going to try and continue with this exact same strategy, and you're going to see that I've actually already built all this stuff into our game engine for you. Whether you're working in the Java engine or whether you're working in the C# engine, it's already there. You just need to take advantage of it. And now I've made some pre-existing states for you. Pretty much all of these ones, plus or minus a few of them. And if you know you're not going to need some, just delete them. If you know you're going to need more because you have a different type of game, then add them. Now, some people might say, oh, what if I have multiple levels though, Mr. Lane? So do I have like a gameplay level 1 state, gameplay level 2 state? No, 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 no. You still have just a gameplay state, but you also have a level variable. And that level variable is an if statement inside of the gameplay state. So inside of the draw, you'll say if level equals 1, you draw the level 1 stuff. Else if level equals 2, you draw the level 2 stuff. Similarly speaking, in update, you're probably not going to change your update code, because depending on your game logic probably won't change for gameplay if you're on a different level, unless it's like a completely different situation. So for example, in Super Mario Brothers, level 1 he's running and jumping and everything like that, but a few levels later he's swimming, so his complete control mechanism completely changes. So that's game state. And believe it or not, you can use this idea of states for almost everything in your game. So for example, you might have a player state. So is the player running? Is the player jumping? Is the player walking? Is the player standing? Is the player sitting? Is the player dying? Every one of these states, and you could have that as another switch statement inside of your switch statement. So the player's always doing what they should be doing when they're supposed to be doing it. The player always looks the way they're supposed to look when they're supposed to look that way because of the player state. You could do that with everything in your game. Maybe you have bullets, and the bullets are moving in one state, and then the next state they're exploding. It's things like that. So use this idea of states and apply it to whatever makes sense within your game. So that's all we're going to do for the intro. Going forward, we're going to start to look at something a little bit more specific to the game engine that you're going to be working in, whether that is the C# engine, the game engine, or any of the other graphical engines that we use inside of our courses, whether that's Monogame or the Java game engine that's built for Eclipse, depending on when you're watching this video. Thanks for listening.